Today we're going to cover section 1.4, word problems. All right, so when we do this is going to be our same three system variables, but now with word problems. So an amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. There are 3 times as many seats in section B as in section A. The revenue from selling all 23,000 seats is $870,000. How many seats are in each section of the amphitheater? So the first thing I need to do is define my variables. A are going to be seats in section A. B are going to be seats in section B. And L are going to be lawn seats. And as we can see from the picture, there should be more lawn seats than section B and more seats in section B than in section A. So now we need to think about setting up our equations. Our 3 equations here, our first equation is going to be talking about the number of seats. So when we do this, we're going to say the seats in section A plus the seats in section B plus the lawn seats equal 23,000 seats. That's going to be our total number of seats. Our second equation is going to be a money equation. So when we think about it, it's $75 for a seat in section A, it's $55 for a seat in section B, and it's $30 for a seat in section C, and that's going to equal $870,000. Now our last one here says there's 3 times as many seats in section B as section A. So really, sometimes these can be tricky. So it's either going to be 3B equals A, or it's going to be 3A equals B. I like to go through and just plug a number in to make sure I'm right here. So if I said, well, if B equals 1, that's telling me that if there's 1 seat in section B, there's 3 in section A. That's not what we're looking for, though. We're looking for this one here. So saying if there's 3 seats in section B, there's 1 seat in section A. So our third equation is 3A equals B. Now, when we go about this next part, we can solve the system any way that we can, elimination or substitution. Because our third equation already has a variable solved for it, I'm going to use substitution. So I'm going to sub 3 into 1 first. So we'll have A plus 3A plus L equals 23,000. So now I'd have 4A plus L equals 23,000. And this is going to be our new equation 4. I'm also going to substitute equation 3 into equation 2. If we now do our multiplication, this is 165A plus 30L equals 870,000. We combine like terms. So this is our new equation 5. Now, we need to get rid of either A or L in equation 4 and 5. Just because I see it, here you could solve for L here and use substitution. I just like to use elimination, so I'm going to use elimination with 4 and 5. if I get rid of L, I need to multiply the first equation by negative 30. So that'll give us negative 120A minus 30L equals negative 690,000. I just move my second equation over. When I add these equations, I get 120A. The L's cancel out, equals what is that? Let's see here, 87,000 minus 690,000. 18,000. When I divide by 12 or 120, I get A equals 1,500. So now, once we have our A, we're now going to plug A back into B. So I'm going to plug it into equation 3 because it's one step. So we're going to plug A into 3. So now we would say 3 times 1,500 equals B. So 4,500 equals B. And now I'm going to plug A and B into, I'm a simpleton, so I'm going to plug it into equation 1. So we'd have 1,500 plus 4,500 plus L equals 23,000. So 6,000 plus L equals 23,000. So L equals 17,000. So when they want to know how many seats are in each thing, there's 1,500 seats in A. There is 4,500 seats in B. And there's 17,000 seats on the lawn. And that does satisfy our equation here, saying that there's 3 times as many seats in section B as there is in section A. Okay, so that's our first word problem that we're going to do today. The second one also has to deal with money. So when we look at our second equation here, it's telling us that Jordan has $1.27 in quarters, nickels, and pennies. He has twice as many quarters as pennies. He has 11 coins total. How many coins does he have of each? So when we do this, first thing we're going to do is start off by defining our variables. So in this case, I'm going to use Q for quarters, N for nickels, and P for pennies. Okay, so our first equation is going to talk about our total number of coins. So we're going to say Q plus N plus P equals 11. So that's our first equation. Our second equation is going to be our money equation in this case. And if we think about money, a quarter is 0.25, a nickel is 0.05, and a penny is 0.01, and that's going to equal $1.27. Now our third equation here, once again, he has twice as many quarters as he does pennies. Our two choices would be 2Q equals P or 2P equals Q. If we go through and plug our values in again, we end up getting the equation 2P equals Q. So now, just like the previous one, I'm going to use substitution to start. So I'm going to say 2P plus N plus P equals 11. So 3p plus n equals 11, and that's going to be my new equation 4. All right, now I'm going to sub 3 into 2. But before I do that, I'm going to make my lives a little bit easier. I don't like all of these decimals here. So what I'm going to do is I'm going to multiply the whole second equation by 100 to get rid of all the decimals. So when we do this, this will now turn into 25q plus 5n plus 1p equals 127. That's just going to be easier for me going through solving this, that I don't have to worry about different things with substitution. We can always multiply the whole entire equation by a value and not change it. So multiplying by 100 here doesn't change the value of anything in the equation. So now I'm going to plug in 2p for q. So now I'm going to have 25 times 2p plus 5n plus, I'm just going to write p now because there's one of them. So I have 50p plus 5n plus p equals 127. So my equation 5 here is 51p plus 5n equals 127. So now that I have equation 4 and 5, I'm going to use elimination with 4 and 5. So I have 3p plus n equals 11, and 51p plus 5n equals 127. I'm going to multiply the first equation by -5. The second equation is fine, because now our n's will cancel out. When I add these things together, I'm going to get 36p equals 72. Divide by 36, so p equals 2. That tells me I have 2 pennies. So now I'm going to sub p into 3. So when I do that, 2 times 2 equals q. So 4 equals q. All right, so now we have q, so now we're going to sub p and q into 1. So now we would say 4 plus n plus 2 equals 11. N equals 5. So to write them in alphabetical order like we normally would, we would have 5, 2, 4. And if we refer back to what we had up here about quarters, nickels, and pennies, this is saying that we have 5 nickels, 2 pennies, and 4 quarters. And we have twice as many quarters as we do pennies. The homework for today's lesson will be posted. Please reach out if you have any questions. Have a great day. Bye.